Solve the problem. Laura Tannenbaum paddled her canoe 10 miles upstream and then paddled back to her starting point. If the rate of the current was 3 miles per hour and the entire trip took 3.5 hours, what was Laura's rate? Well, we've performed step 1. We've read the problem carefully. In step 2, define your variable. Let's let x represent that thing we're trying to find, Laura's rate. Let's make a note that this is a distance, rate, and time problem. And let's use a table to organize our information and use that to write our equation. Now, if the rate of the current is 3 miles per hour, then downstream, Laura can go her paddling rate plus 3, or x plus 3. Upstream, she's fighting the current, therefore her rate is slower, it's x minus 3. We're told that she goes 10 miles upstream and then back, so 10 for both of these distances. And in using our d equal RT formula, solving for time, time is distance over rate. So the time upstream is 10 over the rate x minus 3. Downstream, 10 over the rate x plus 3. Now we need an equation. We're told an additional piece of information that it took 3.5 hours to do this. So the sum of these times is equal to 3.5 hours. Let's write that equation. The time upstream, 10 over x minus 3, plus the amount of time it took coming downstream, 10 over x plus 3 is equal to 3.5. I'm going to write that in improper form as 7/2. Now we've completed step 3, we've written our equation. Step 4, let's solve. Here we have a rational equation. I'm going to multiply through by a lowest common denominator to get rid of these fractions. That lowest common denominator is 2 times x minus 3 times x plus 3, and you can think of that over 1. Now let's multiply. So we take this times our first term, the x minus 3's cancel, leaving 10 times 2 times x plus 3. As we multiply times our second term, the x plus 3's cancel, leaving 10 times 2 times x minus 3. On the right-hand side, the 2's cancel, and this gives 7 times x minus 3 times x plus 3. Now let's solve this equation. Up front, 10 times that 2 is 20. We'll take that times x plus 3 in the next step. Second major term here, we have a product of 20 again, times x minus 3. On the right-hand side, let's multiply. This is going to give us a difference of squares, x squared minus 9. Distributing now, 20x plus 60 plus 20x minus 60 is equal to 7x squared minus 63. Now, this has resulted in a quadratic equation. Let's put this in standard form. I'm going to move everything to the right, set equal to 0 on the left. We'll have a 7x squared term on the right. On the left, we have 20 plus 20, or 40x. Let's subtract that from both sides, where it becomes a minus 40x on the right-hand side. And let's see, our positive 60 and negative 60 on the left cancel out. That leaves us with a negative 63. Let's solve this by factoring. If it factors, it's going to factor as the product of binomials, where our leading terms have to be x and 7x to give a product of 7x squared. Factors of negative 63 that are going to work in here are a minus 7 and a plus 9. Let's check. Negative 49x plus 9x does result in negative 40x, so that's good. Using our zero factor property, x minus 7 is 0, or 7x plus 9 is 0. So x is equal to 7, or subtract 9, divide by 7, x is negative 9/7. Now, remember that x represents Laura's rate. Her rate is not going to be a negative number, so let's reject this as a realistic solution. Okay, that one's gone. Let's focus on this x equals 7, however. Remember that this is a rate in miles per hour. Just make a quick note there. Let's go ahead and check this. Let's check it in our original equation, which was 10 over x minus 3 plus 10 over x plus 3 is equal to 7 halves. Let's substitute 7 in there and see if this works. This is our last step here. So is 10 over 7 minus 3, that's 4, plus 10 over 7 plus 3, that's 10, equal to 7 halves. Well, 10 over 10 is 1. 10 fourths, that's a 5 halves or a 2 1/2. Is that equal to 3 1/2? Sure is. 2 1/2 plus 1 is 3 1/2. That is true. Our correct answer then is 7 miles per hour. Let's make sure we just summarize that very clearly. That is Laura's rate. L-A-U-R-A, right? Laura's rate. It is 7 miles per hour.